we can all see the pattern here, right? This reoccurring square. Now, if I then said, here is a sequence of numbers, tell me what the pattern is, you would tell me, well, there is a difference of 3 for each term. Now, because of this, we can say that this sequence of numbers follows an arithmetic sequence. Now, after 25, what would be the term? It would be 28. And then after that, it would be 31, right? And then we could keep going up until our 50th term, up until our 100th term, right? Up until the last term wherever, right? Up until infinity, all right? There is no end to the sequence. But if I wanted to know my 50th term, I could use a formula. And the formula states this. It says that an is equal to a1 plus n minus 1 times d. Now, once again, this is only for our arithmetic sequences where we have this difference. And the difference is represented by d, which is a 3. N is the term that we want, in this case would be 50, and A1 is 4. So A1, A2 is 7, A3 is 10, A4 is 13, and so on and so on. Right? So if we wanted to find our 50th term, I would say that A50 is equal to 4, our first term, plus N50 minus 1 times D, our difference in this case is 3. Right, which would then equal to 151. That's pretty cool, right? Now, there is something I could change in the sequence to create a series. Now, what would that be? Well, let me show you. What if I just added an addition sign between all these terms? So 4 plus 7, 7 plus 10, plus, and boom, and so on and so forth. And we added all these terms, all of them, up until our 51st term. Okay? And so, how would I then find the summation of all these numbers? All right? And there's something I want to show you. It's another formula. This formula states that Sn, the summation up until the nth term, is equal to n divided by 2, 2a plus n minus 1 times, again, d. All right, and that is a super cool formula. So if I wanted to just sum the first 3 terms as kind of an exercise, I could say, well, s of the first 3 terms would be 3 over 2 times 2 times 4 plus 2 times 3, our difference, right? And we know that would be 3 over 2 times, well, that would be 8. 8 plus then 6, which would be 14. 14 divided by 2 would be 7 times 3, which equals to 21. And we can see, well, 10 our third term, plus 2 our second term is 7, plus 4 would actually just give us 21. So the summation of these 3 terms is 21. And so we know this formula works. Now, just as an exercise, I want to say, well, what would then be the summation up until our 51st term? Okay, so let's see, this would be pretty fun. 51st term equals 51 over 2. 2 times a we know would be 4, plus n, we know 51 minus 1, times d, our difference, 3, and that then equals to 51 over 2. 8 plus 50 times 3 would be 158. 158 then divided by 2 times 51 gives you 4,020. And that's pretty cool, because any sort of sequence of numbers, as long as we see some sort of pattern, we can then find a way to then sum all these numbers. I could have said we're plussing all the way up until our 100th term. Okay, and we can keep doing this all the time. And so you can see how this can be quite helpful when you're doing things like finances even, okay? Super simple things that might need just a sequence of numbers that you might see a difference for, all right? Thank you so much for watching. It's Curated. I hope you have a great day. Stay happy, stay healthy.